Okay, so next unit we have is graphing systems of inequalities. So we're taking the lesson from the last one, right, where we just graphed one, and we're going to level it up. So we got graphing systems of inequalities. So a system, if you don't know what that word is, it is when you have two or more lines on the same graph. It might not be straight lines. Honestly, the word that would be best to use is functions, but for what we are doing in this chapter, in this unit, we'll call them lines. So it's having two or more on the same graph. Okay, now systems of inequalities have answers, right, in three places. One is in the double shaded area, right, because yesterday we proved that if it was shaded, if a point was in the shade, then you could say that it was a solution. We did that mathematically where I was doing too much. You can also find answers where there's an included line intersection. Okay, those are the solid lines, so that's where they cross. And then also, a third place that we found kind of in class was included or solid lines next to the double shaded area, right? So basically it takes these two first answers and kind of like combines them a little bit. So we're gonna talk about that, show it. I might buff out a piece of paper on the side just to prove it real quick because I like to do too much. We are doing more examples than we did in class, but if you need more examples, this is a good video for it because none of these are the same ones from class, even better. So we're going to start off with this first equation, right? I'm going to use colored pencils just so you could see, and I'm going to use primary colored pencils because let's integrate two topics, right? We're going to talk about math and mixing colors. All right, so this first graph we'll make red. We'll make blue because that's the pencil I grabbed. Now this this equation is ready to go. It's already in slope-intercept form, right? We could figure out our slope, which is -1/2. We got our b, which is -2. All right, so I'm gonna use my pencil to help me plot the points. We start at -2, and then this slope tells me to go down and right, and I'm using a pencil, so if I make a boo-boo, I can easily erase it, because this is a video and that would be embarrassing. So we go down 1, right 2, down 1, right 2, down 1, right 2. And the other way, we go up 1, left 2, up 1, left 2, up 1, left 2. This is nothing new. This is stuff we've been doing, so that is why I'm going through it pretty quickly. My inequality here from yesterday, this tells me it's a dashed line because it is not a half equal sign. So I'm going to make a dashed line through these points using my colored pencil. And remember, any point on a dashed line is not a solution. It would not be true. So that's why we call it the not included. And then we also have to shade. Now we have a bigger y. Okay, so because we have a bigger y, that means we shade the bigger y's that we see. The bigger y's that we see are above here, right? So I use that arrow to kind of help me out. And that means I shade here. Don't go past, though, your drawn dashed line here, because that stuff, anything past that line is a no-go. It is not part of your answer. All right, now notice my coloring is not perfection, okay? It's just, pretty good, not great, and that's okay. Next up we have is our second equation that's going to go on this same line, but we need to notice that first, there's no y, right? For it to be slope-intercept form, it's got to have your y and your x. This one has no y. Okay, so that means it's not going to be diagonal. Your options are either going to go side to side or up and down. The only way it's diagonal is if it's got both the x and the y. This one doesn't. So what I do know is I got this x, so I know I'm looking at the x-axis, and it's -2, so I know I'm going to -2. So the only way I can go through just that -2 on the x-axis is by going straight up and down. Because if I try to go side to side, then all of a sudden I'm hitting all of the x values, and that's not what I want. I only want to go through the x value at -2. So that's why we go up and down. And it's going to be a solid line because we have a half equal sign. And now I know we don't have our y's, but we do know that this x is smaller. So we'll talk about that here in a second once I draw my line. So I got a nice solid line here. Okay. Now I know I need my smaller x's, so I know I'm focused on my x-axis because I can't say up or down because this line is going up and down, so that doesn't make any sense. I can't shade up or down on both sides because then I'm shading the whole thing. So what I'm looking at is the x values because that's all I got going on right here. So where do I find smaller x values? Well, I find them to the left. And I know there's shading here, but right now we're going to ignore that shading. We're going to pretend it's not there and just focus on shading to the left of my red line. Okay, so together we have what we'll call this is our purple area, right? Because red and blue make purple. So what we're going to do is we're going to look at the intersection point. So this is where it intersects when we're calling this point A. Okay? Point A, so we're going to talk our way through this. We're not going to math our way through this. So point A, right, for the blue, it's on the dashed line. So that is not true for the dashed line, okay? But for point, the red line, right, for the red line, it's solid. And yesterday we talked about if a point is on a solid line, it would be true. Now, I know that it's true for this solid line. However, it's not true for the dashed line. So it's not a solution because one line is not included, right? AKA it was dashed. Okay. Because when we talk about a system, if it's not true for both of these, then it's not going to be true at all. It has to be true for both. Okay, and remember, true, I'm going to write this over here. True equals a solution, right? And if you have something false, then it's not a solution. Okay, I'm going to start using the word solution instead of true and false because we're leveling up in our math here. All right, so because it's not true for the dashed line, it's not true at all. Okay, so point B, I'm going to put right here. Point B, so let's think about point B with just the blue graph. So for the blue graph, point B is true because it's shaded, right? That's good. And then let's look at the red one. So we know it's true for the blue, that's good. For the red one, point B is also true because it's in the shaded area. So that is good. So both of them are good. So that means we have point B being a solution because it is shaded by both, right? Both equations have point B in its shaded area. All right, next up we have, I'm going to pick point C over here. So point C. So when I look at point C for this first one, point C is true, right, because it's in that shaded area. But for the red one, right, point C is false because it's not in the shaded area. So once it's not true for one of them, it's not true at all. So that means it's not a solution because not shaded in both. Okay, it's not shaded in both, right? It's not shaded in that red area. Okay, so it's not gonna work. That's why it's not a solution. If it doesn't work for both, it doesn't work at all. All right, next problem here. So we got y equal, so we only got to 2 problems class, so this is kind of like our second problem from class. So first things first, we have this first equation. It's ready to go, right? It's got y by itself, it's got a y and an x, so that means it is slope-intercept form, which is super great. I am going to plot my points in pencil, so I got point starting at 2. My slope tells me to go up and right, so I'm going to go up and right. And remember, this is a video, so you are more than welcome to pause and rewind, or pause. I have my slope, This is telling me that it's solid. So I'm going to make a nice solid line through these points. This is telling me that my y value is smaller. So where do we find smaller y values? We find smaller y values below. So that means I'm going to shade below. Notice how my shading is not super great. I just make sure I'm paying attention to by the line. So we got this solid line here. Gotta make sure it's really solid. All right, this next one is not slope-intercept form because we need to get y by itself. So we gotta do some math. So the first thing we want to do is minus that 2x. And if you do it on one side, do it on the other. But I'm going to put this one to the side because these are not like terms. So now we're left with negative y is less than or equal to 3 minus 2x. I do have a negative still next to our slope, or I'm sorry, to our y. So I'm going to get rid of it. And I do that by dividing. And then when I divide on the other side, I got to divide all of the pieces. But we got to be careful because when we divide by a negative 1, this gets changed to, I'm going to put it down a little bit lower. It gets changed, it flips whenever we divide a negative across the equal bar. So this y, 3 divided by negative 1 is negative 3. Negative 2 divided by negative 1 is a positive 2x. So now we have, let's see if you guys can see that. Yeah, you can see that yellow. So we now have our slope and our y-intercept. Our slope, remember, is going to be a little bit in the back here, so it's going to be that 2. And I'm going to put a 1 under it. And then my y-intercept is negative 3. Okay? I'm really glad you can see it on the video because I can't see it in real life very good. So I start at negative 3 for my y-intercept, and my slope tells me to go up 2 and right 1. And I can do that pretty much all the way through. And I can do it backwards as well a couple spaces. I'm going to use my pencil though to help me draw the line for this one because it is yellow. Alright, and I don't want us to not be able to see it. So we're going to have a solid line because we have the half equal sign, and we're going to shade the bigger y values. Okay, so I'm going to draw, I don't know, let me see if I can get it. Let's see if we can see it on the document camera. Oh yeah, you can see it. Okay. So we have a solid line here, and then it says that we have to shade the bigger y values. So the bigger y values are going up from that line. So I'm going to shade up from this line, even though we're going to pretend that red one is not there. Alright. So once we shade all of that, now we have to look, right? So we know that an answer right here would be true because it's in the double shade. It would work for this one and it would work for this one, so it would be straight up a solution. This one would not work, okay, because it's only for this one but not for the red one, so that's a no-no. And then over here, this point, right, this would be a no-no because even though it works for this one, it doesn't work for this one, and it has to work for both. Okay, now I want to look at the intersection. So we got point D here, right, the intersection point D. All right, now this D for the red is on a solid line, and if it's on a solid line, it's true, so that means it would be a solution. And then for the yellow, it's also on a solid line, and if it's on a solid line, it's true, and then it's a solution. And since it works for both, it works all together. So point D for this intersection is a solution because it's on two included, let's use the fancy math word, included or solid lines. Okay, so that works out. And then this point would also be true because it's on a solid line and it's being shaded by the red area. I'm sorry, the yellow area. All right. So in this next problem here, right, we got slope-intercept form already, right, because we got both the x and the y, and we got the y by itself, so we're good to go. My slope in this case, well, this has a regular x, so we put a 1 in front of it to help us out. So we got 1 over 1, and our y-intercept is 3. So I'm going to use my pencil. Start at 3, go up 1, right 1, all the way through, because we have positive 1 and a positive 1. And then I'm going to extend my line in the other direction as well. All right. So from here, we decide our dashed line here because it is a regular a regular mouth. So I'm going to make a dashed line. Make sure it's very obviously dashed, you know. If I have to guess, I'm going to assume it's wrong. Okay, and then we look at our y value. So the y in this problem is smaller, so we need to find our smaller y's. So smaller y's go down from the line, so that means we're going to be shading below. So remember, be very careful about how you shade by the line because I am going to be a psychopath crazy pants about it. And then the rest of it, shade out as best you can. If you want to make it perfect, that is a you choice. I love that for you. Next problem, we got a y and an x value, and the y is already by itself, so that means we got it in slope-intercept form. So my slope in this case is next to the x, and it's a negative 3 over 2. My y-intercept is this negative 2. I'm so glad you can see this yellow on the screen because I can't see it really good. So we start with our negative 2 here. Our slope is negative, so we got down and then we got right. So we got down and right. I can do that just one time, and then I gotta go in the other direction as well. So here's my intersection. Keep going, keep going. And then looking at this, we see that we are going to use a dashed line again. And we see that we got a bigger y. Okay, so let me make my dashed line. Dash, 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 dash. All right. And then if my y value is bigger, right, that means from this line I got to shade above it. Okay, so that means I'm going to shade all of this stuff above the line, making sure that I do not pass my yellow line. And it's okay if we have a double shaded area, because honestly, that's what we're looking for. Okay, so question. Point E, the intersection, right? So this is my intersection right here, point E. Is it a solution? Well, let's find out. So for the blue line, it's on that line, but it's not going to be a solution from yesterday. It would not be true because it's dashed. So already it's not looking good. Same with the yellow. It's on a dashed yellow line, right? So again, that's not true. We figured that stuff out yesterday mathematically. So already, even though it was already, not true for this one, that would automatically make it not true. So this is not a solution because both lines are not included. Right? Once it's not true for one, it's not true for both. So remember, not included means dashed lines. Okay. Now, that to be fair though, like this over here, this would still be a solution because it's true for the blue, it's because it's shaded in blue, and it's true for the yellow because it's shaded in yellow. So please don't get that confused, right? A point here, let's just write that out. So just in case if you're not listening to the video. So point F is a solution because in both shades. All right. double shaded, yeah, areas. We'll keep it like that. Okay? Boom, boom. All right. So don't like get that confused, right? Even though the intersection don't work out, the double shaded area, you still find solutions. Okay? All right. I'm going to flip. Boop. Last one, best one. All right. So first things first. I think the only color combination, I think I've done all of them now. So we're going to start with this friend. We got y is less than or equal to 3. Well, first things first, I notice there is no x. Okay, if there's no x, it's not diagonal. Okay, that means it's either going to be straight up and down or it's going to be side to side. So we know we got y, and we know we got it at -3. Okay, all right, so we know our line is going to be solid, and we got a y, so we know this is a smaller y. Okay. Well, the only way that we can have it go through only this -3 is to go across, okay? Because if I go up and down, well, now all of a sudden I'm hitting all of these y's, and that's not what I want. I only want to hit this one. So I'm going to have to go just across. So I'm going to make it nice and solid. A bold, solid line. And then it says y is smaller. Well, we've been talking about this. Smaller y's are below. So I'm going to shade below. Next one here is not ready, right? This is the standard form. This is the fancy name for it, right? To get it to be y-intercept, we have to get the y by itself. So we're going to try and get this by itself. So first things first, we're going to subtract 6x. And if I subtract on one side, I got to do it on the other side. But I'm not going to subtract it from this 3 because they're not like terms. So I'm going to kind of put it to the side. So we got y. My mouth doesn't change if I subtract. 3 minus 6x. And now it is in slope-intercept form. Okay. I don't have to flip my inequality because the only reason you flip an inequality is if you multiply a negative on both sides, like where you're trying to move one from one side to the other, or if you have to divide a negative all the way through. Okay, so we got our slope. Our slope is the -6. Our y value is that +3. I'm going to change this to a fraction because I need it for graphing. So I'm going to start at 3. And it tells me to go down 6/1, and I can only do that once. I'm going to make this fast because my kid is crying in his crib. This is a dashed line, and my y value is bigger. So I'm going to make this a dashed line. Okay, y value is bigger, so that means I need to go to the bigger y, so I'm going to shade this side. I'm going to tell you, I was really bad at shading in high school. I just could not figure it out. And then all of a sudden I became a teacher, and I don't know what happened, but I kind of figured it out on my own. I'm going to make my line dashed with my pencil because it doesn't seem dashed when I start coloring. Okay, so the intersection point F here, so where they cross paths is right here, so this point F. All right, first things first. For the red line, it would be true, right, because it's solid. But for the blue line here, it's not going to be true because it's dashed. So once one is not true, then it's not a solution because one line is not included. And remember, not included is the fancy way of saying something about those dashed lines. Okay, now remember, this still works. These are still solutions here. Okay, that's still solutions because this is where the double shade is happening. This don't work. This ain't a solution because the red is missing. This doesn't work because the blue is missing. Okay? Alright, that's the end of this video. There were extra problems compared to class, but they were all different problems compared to class. So if you needed a little bit extra, this was for you. Alright, have a good day. Have a good evening.